Wright minor, and I also worked like a kids environmental education summer camp this summer, kind of focused on the story that you guys are talking about. So.
And then we also have Dr. Pete Goulet from Emory School of Forestry. Hi. And basically, I asked them to come today, and I think Karen Ellis Clark is supposed to be here, and she's from the Forest Service. And I asked them to come today really to give you guys the big picture of what are we trying to convey to these elementary school students. And what we're really trying to do too is make it very entertaining and fun, but they're learning at the same time. And they're learning about the importance of our forest health issues, which Pete and the students are going to explain further. Also, we're worried about all the wildfires that occurred this year, so teaching them about wildfire safety and putting campfires out. Also, flash flood safety, because we also have a lot of problems with that in our community as well. So we asked Pete and Dr. Goulet and the forestry students to come here and give you a big picture overview so that you understand what you're trying to convey. And you all are going to be writing the script for this to be delivered to these elementary school students in this production. And then Hope and Kate will also help you with writing the script. They're going to work with you more in the long term. So I'm going to hand it over to Hope and Kate and Pete, and let them talk to you about the big picture and the overview of what you're trying to create here. And Mike, I don't know if you wanted to add anything to that.
Well, we've already talked about the kind of the overarching project and timeline and what's happening and what's all about. We don't really have an idea yet, but we have the seed on it. Where is that coming?
I also, do you want to introduce yourself as well, Ken? And as you're writing this and you forget what has been presented, then you can replay this and look at this again. And so we're going to try to document the whole process, the rehearsals, the actual performances, maybe some of the, when they're creating the props and the scenery, things of that nature. So it's a really multi-generational project. We're going from college professors, college students, to high school students, to middle school students, to elementary school students. So this is really an incredible project. And I'm just really excited about it, and I know Mr. Levin is too. And I know Dr. Goulet, when I told him about it, he was like, "You bet I want to come over and talk to the students." So I'm going to hand it over to Pete and the students and let them talk to you about the big picture overview of forest restoration. I'm going to let you sit there, Pete.
So, what do you guys know about how our forests have changed in northern Arizona and the southwest?
I know when they first created Flagstaff before it burned down multiple times, they just kind of raised the entire forest.
Mm-hmm.
So a lot of the older forest isn't here anymore. So a lot of the younger trees grew, and that's why a lot of our forests are so cluttered.
Mm-hmm.
So.
Okay, yeah, that's excellent. So actually this morning, I was out west of Flagstaff in an area that was logged really early on, shortly after the railroad got here in the 1880s. And we were looking at the old railroad logging tracks. So before there were trucks and before there were chainsaws, they used to they'd create spurs, they'd create sidelines off the railroad and go way out into the forest, cut as many trees as they possibly could. If you had all the trouble with building a short railroad line with basically hand tools and animals, you're going to try to take every single tree. It's just nothing but stumps. So a lot of the old forest was gone, younger trees came in, and what else? What other kinds of things that changed? So you guys already know all this stuff we're going to talk about, so I figured I'd just ask you about that time.
Yeah, what's it?
Didn't they not realize, well, when they first came here, they didn't realize how long it took the trees to grow. So they logged them a lot more, and then they were growing really slowly. They didn't know why they weren't coming back. Or was that something like that?
There's something to that, yeah. Ponderosa pine naturally. I mean, this is really a desert. You know, when we think of it as a forest, and from an Arizona perspective, this is kind of a wet place. grand scheme of things around the world, this is a pretty dry place. And so our trees don't grow very fast, they don't regenerate. Very good conditions, and we ended up with a pretty dense forest. So what about fires?
Well, we've had a lot of them lately.
Yeah. Is that unusual, normal?
Maybe not the amount of fires that we're having, but how extreme they've been. Like with the last one on Schultz Pass, that was a very destructive fire, and we had a great view of it from our house. And with what happened in the Peaks a couple of years ago, when the one runaway girl accidentally burned down like the entire mountain, they were comparing it to that and thought it would remember them. And so
That would be the radio fire in 1977. That
that
burned up Mount Eldon, so when you drive around east,
I don't remember it being that delicious.
The system alive, really, both like soil regeneration and everything else. But I think humans in the Flagstaff area have definitely contributed greatly to the severity of these fires, and if a fire is like really severe, it might just wipe out an entire ecosystem.
yeah, that's really good. And so some of these changes that we've been talking about of having a forest that would have had some really big trees are actually pretty resistant to fire because the branches are high up, fire can pass through the surface below and not necessarily turn into a crown fire like the Schultz fire that runs through the tree crowns. But we replace that with a lot of young trees, make the forest more dense, it's more susceptible to fire. So that's kind of a little bit of the story of what's going on here. I knew that you guys already knew that. I did want to show you though an example of how we know some of this stuff. This is what I want to do. And I don't know, you guys might want to come down and take a look. This is kind of cool. This is a partial cross-section from a tree, right? So here's the bark. So in the tree, it's like a piece like this, if I was a tree. We cut it without cutting the tree down. It didn't kill the tree. It's not good for it, but it didn't damage it in any permanent way. And so what are all these little black marks on it? Excuse me? Kind of, yeah, you can see it's black. If you look at it this way, it's charred. You can see these all around on trees and especially on stumps because we cut down most of our old trees. This tree was burned many times, and when it was burned, it's not just that it was burned, any piece of wood can be burned, but it was damaged in the part of the tree that's alive. So the part of the tree trunk that's alive, which might sound weird, why isn't the whole tree trunk alive? But it's not. There's certain cells in the trunk of a tree that are alive and reproducing, and the rest of the cells are dead, kind of like your hair or your fingernails. What's the part of a tree that's alive? This school specializes in biology, right?
Primary or secondary xylem or phloem or those.
You're doing great. So xylem is wood. Xylem cells are wood, and phloem is a narrow band on the outside of the wood, but underneath the bark, that conducts the nutrients. So the xylem tissues carry water from the roots up to the leaves, keep the top of the tree alive. The leaves are producing sugars that get sent back down through the phloem to keep the roots alive. So that's how the whole thing works. And that thin band of living tissue has what's called a tissue that can grow and reproduce. It's alive, and it's called the cambium.
That's what it is.
Yeah. So the inner ring of this tree is from 1606. So that's 404 years ago. What was going on in 1606 in the Southwest? That's, Santa Fe just had its 400th anniversary, I believe. So the foundation of Santa Fe, foundation of Flagstaff, way later, right?
Shakespeare was going to retirement.
That was going to be my next reason. So in the year 1630, the cambium of this tree was damaged. And we can tell it's damaged because it left a scar. Like you can have a scar on your body. It didn't kill the tree because then it would have died 400 years ago and we wouldn't be finding it and all that. But it damaged it. And the damage became like an open wound on the tree that as time went on, future fires could make new scars on. Because instead of being surrounded by a pretty thick bark, it was an area that's real vulnerable. These trees also protect themselves by pitching resin into areas that are hurt. Resin is flammable, like sap of pine trees, and so it helps it scar time after time after time. So this tree scarred in 1634, 1646, 1648, 1652, on and on and on and on. And from studying not just this tree, but many trees like this, we get an understanding of that long-term pattern of fires. There are other forest types in Flagstaff, some of which, like aspen or the spruce that are high up on the peaks, are adapted to not have lots of surface fires that just scar the tree, but instead have severe fires that kill those trees. But they only have those fires every 100, 200 years. These kinds of trees, ponderosa and some similar trees like Douglas fir, had fires very, very frequently. So we can use samples like this to figure that out. We can know these dates because they're actually not printed on the sample when you take it out of the tree, unfortunately. We know these dates by matching the patterns of the tree rings. So it's not based on counting tree rings, but actually looking for patterns that are caused by droughts. Because when there's a drought, if we were all trees, we might grow at different rates. There might be more competition over here. You guys would grow more slowly, and you would grow more quickly because you're all by yourself. But when there's a drought, everybody suffers. And so if there's a drought, and then 3 years later another drought, and 10 years later another drought, you can match those patterns up and determine the exact dates of these things. So we're cruising right along until we get to 1869. This sample's from northwestern Arizona, what's called the Arizona Strip. After 1869, there's no more fire scars passing around the excavator. So why would that be?
Well, I think when we got here at Flagstaff, we definitely started like suppressing the fires as much as we could. Like as soon as there was a fire, the fire station goes like puts it right out.
Mm-hmm. That's true. And somebody made a comment about Flagstaff burning down several times when it was first established. You said that? Yeah. So people were very scared of fire, and also Flagstaff was to some extent built on a timber economy. You didn't really want the fire burning up the forest and all that kind of thing. The only thing is though, so 1880, 1885, 1890. In those days, we didn't have helicopters and airplanes and buses full of fire crews and all that kind of stuff. And as it turns out, the actual suppression of fire sort of effectively is a lot younger than that. It's really only, in a lot of places, the 1930s, in the Depression, when the government put together groups of people who were otherwise unemployed and had them go out and work in the woods and places like that. That's when they really started suppressing fires everywhere. They tried to earlier, but they weren't that successful all the time. So what could have happened around 1880 or even 1870, like 30, 40, 50 years earlier, that could have caused fires to stop?
Lots of rain?
That's a possibility, right? You could have a sudden climate change. If the climate had changed suddenly in the 1870s and it became a lot wetter all the time and just so soaking wet that things just couldn't burn for 40 or 50 years, we would know that. Actually, all those pioneers and whatnot would have been extremely happy. They would have been planting fields of wheat all over the place or whatever. We would also know it from weather records that they kept and from the tree rings themselves, because the tree rings are very sensitive to climate. So we know that climate, there was actually a couple of droughts in there. In the late 1870s, a big drought, and right around about 100 years ago. But the climate didn't change too much, although that's certainly a possibility. So what else could have happened?
Did we cut down all the trees around it so that there's nothing?
Cut down every single tree so there was nothing to burn? There are probably some places, like where I was this morning, where if you had stood there around, I got to guess when they built that particular railroad, but about 1910, about 100 years ago, there was probably not a whole lot. I mean, you might see one tree here and one there that was too small to mess with, and otherwise they cut everything down. But that's not universally true. This area, for instance, where this sample comes from, still today has a lot of very old trees.